in this video we'll be talking about the conformation of cyclohexane. Conformation is simply the different spatial arrangements of atoms around a single alpha bond without breaking it. Remember that cyclohexane does not rotate easily, just like an open chain, because of its ring. So it adopts spatial shape in order to reduce strain. Because of time, I'll just go straight to explain to you, to give you a hint on how to draw chain conformation of a cyclohexane. The first thing you will do, there will be two bonds that we'll be going to use here. We will use axial bond and equatorial bond. So the first thing we are going to do is to draw the bond line structure of the chain conformation. Then the second thing is to number the carbon atoms, starting from the carbon that is carrying the substituent group. Maybe we may use something like a methyl cyclohexane here as for illustration, or after that we may use another one. Okay, the third thing is to draw the axial bond first. Remember that in drawing the axial bond uses up and down position. Then the fourth is to draw the equatorial bond. Equatorial bond also uses up and down, but remember that when axial bond, they used to alternate. It's alternate with axial bond. If you start the axial bond, when axial bond is up, the equatorial will be down. When the axial is down, the equatorial will be up. These are the things you have to know. Then the last is to decide where to attach your substituent. This will be very easy because you have already numbered the carbon atom, and you started with the carbon that carries the substituent, that is bearing the substituent. Now let's start illustrating this one by one. First, let's draw the line structure of the chain bond of cyclohexane. Remember, in drawing the line structure, it's always easy to go like this. Draw two parallel lines like this, then draw another one like that. Okay, now put something like a dot here, put something like a dot here. Do you understand? Then connect this to this dot. Okay, can you see? Then this, you connect this to this dot. And that is it. Okay, so in this case now, the second step, I have drawn the line structure of the chain conformation. Then the second step is to number the carbon atom, starting from the one bearing the substituent. Now we are not doing this considering any particular cyclo compound. We want just to get the steps first. So in that case now, I am omitting the second because I don't have anyone I'm drawing particularly right now. So what I have to do now is to draw my axial bond. In drawing the axial bond, I may start here. I just decide, it doesn't matter where you are starting. I'll just start here. Let me clean this hand here. I'll put it here. I'll start, this is what? Up bond. Then this is down axial bond. Up and down, up and down. Okay, so I have finished with the axial bond. So the next is to draw my equatorial bond. In equatorial bond, remember, you're not going to draw the equatorial bond like this. No. It's not like that. So since the axial bond is up here, your equatorial bond will be down. Okay, can you see how I slanted it? Then the next here, this is down, so it means here will be up. this is up, it means the equatorial will be down, right? This is down, it means the equatorial will be up. This is up, it means the equatorial will be down. This is down, it means the equatorial will be up. Okay, I hope it's understandable. Now, with this, the next is to draw. Okay, we have drawn the equatorial, then attach the substituents. This is just it, because we don't have any one now we are drawing, so we are going to pick a particular one now and see how to attach the substituents. Let's assume that we are doing, okay, we talked about this methyl cyclohexane. Methyl cyclohexane, this is the structure of hexane, right? Then the methyl, here we have CH3, which is the methyl. Methyl cyclo what? Hexane. Okay. Now, in this case, what I have to do, I will start numbering. I'll start numbering the carbon number here. Remember that this is metal. There is always what? Hydrogen here. This has hydrogen. Remember, hydrogen bond, hydrogen bond, hydrogen bond. Remember, in which when you are doing it, always remember to attach your hydrogens. Okay. I just have to check which carbon atom is carrying the substituent. The substituent here is the methyl, right? So it means that the carbon atom, this particular carbon atom, I will number it 1. Remember, he said number the carbon atom starting from the one bearing the substituent. Now, this is the one bearing the substituent. This will be my carbon number 1. Now, I will go carbon number 2, carbon number 3. That is, here will be 2, 3, 4, 5, 6. I hope this is understandable. So when I come here, you can see that I went in this direction, right? If I come to assign it here, I'll also go in that same particular direction. I cannot go in this direction and when I am drawing the chair conformation, I will go in opposite direction. No, you follow the same direction that you took when you are numbering it. So in that case now, it means that my number 1, I may decide now that here will be my number 1. Okay? So here will be my number 1, 2, 3, 4, 5, 6. Okay? Now, in doing this, what I will ask now is, where will I attach my methyl? Will it be at the axial or at the equatorial? Remember, when you attach it to the axial, substituents placed at the axial position used to have repulsion, that is steric repulsion, with the hydrogen on carbon number 3 and carbon number 5. Okay, so it's always preferable to attach it to the equatorial bond. Remember, the more bulky the substituent, the more it should be better to attach it to the equatorial. If it's hydrogen only, there is no problem. We can go on and attach it to the axial bond. Do you understand? There will be no issue. But more bulk, you can say that methyl is more bulkier than what? Hydrogen. So we have to attach it to the equatorial because that will give us more stable configuration. So that's a steric repulsion between the substituent placed at the axial position and that of the hydrogen on the carbon number 3 and carbon number 5 is what we called 1,3-diaxial interaction. In order to avoid that 1,3-diaxial interaction, we have to place our substituent at the equatorial bond, and that will give us more stable configuration. It means that Our methyl will be here, right? Remember your hydrogen. Then you place your hydrogen, right? And that is it. Let's use another one for more clarification. Now let's draw this structure. We have, this is chlorine. Now this is chlorohexane, right? So let's start numbering. We have to number, this is chlorine, here will be our 1, carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. Okay, so what will be the name? 2 bromo, 1 chloro, 5 methyl cyclohexane. 2 bromo, 1 chloro, 5 methyl cyclohexane. That is the name. So we are going to draw the chair conformation now. That is the line structure. Exactly, just that structure we brought out first here before we start attaching the substituents. That's what we are going to do right now. Just remember how we started this one. I just drew 2 parallel lines first. This is a parallel line. Then I put the diagonal, I put this. Okay. Then what I will now do is to connect this to this dot. Connect this here. Connect this one to this dot and connect this one here. That will give us the chair conformation. And that is it. So then we start the axial, up, down, up, down, up, and down. Right? Now the next will be what? Equatorial. Then we have down, up, down, up, down, up. And that is it. Okay, now is to attach our substituents. Already we have 1. Okay, let's our 1 be here. 1, 2, 3, 4, 5, 6, right? Now we have that the carbon number 1 here carries the chlorine. So we have the chlorine. This is our chlorine. Then the bromine. Sorry. That is carbon number 2 at the bromine. So remember, this is our axial, right? So this is our bromine, right? Then the next is what? Carbon number 5, which carries what? The methyl. Where is our carbon number 5? This is carbon number 5. This is our equatorial. So this is what? CH3. And that is it. So you just assign your hydrogen. Hydrogen. Remember, this hydrogen is attached here. Okay, let me put this one here so that you don't get confused. And that is it. So is this difficult? So when it comes to the flipping, that is to flip it. During flipping, the only thing that will happen in the flipping is that the equatorial will become the axial. The axial will become the equatorial. But the same numbering and the same structure, it maintains the same structure, layered structure, and the same carbon numbering. It maintains it. The only difference in the flipping is that the equatorial will become the axial becomes the equatorial. Simple. I hope it's understandable.